Read the first chapter on basic perspective terms. It goes over what the station point, picture plane, horizon line, center vision, vanishing point, measuring line, cone of vision. It explains all of those things, but I just wanted to expand on a few of them. So the station point is pretty straightforward. It is the viewer's eye specifically. This is here. The picture plane is this imaginary window between you and the world. You can consider the picture plane to be the piece of paper you are drawing on. Here's how that works. If you had something here, I'm just going to put a circle. And this viewer was to draw this circle. Here is the line of sight. This goes to the viewer's eye. And if they trace the circle on this picture plane, it would be like that. This is the visual pyramid. And this is what the circle would look like. If this picture plane moved closer to this circle, and the viewer traced that, it would be much bigger than this one. It's the same shape. It just changes the scale. If you move the picture plane forward, closer to the viewer's eye, and then you trace that on the piece of glass, it is smaller. The drawing hasn't changed. It's just the scale of the drawing has changed. So if you had a piece of paper that was clear, and you could set it right in front of you, and just trace the thing in front of you, you would have a perfect drawing. But unfortunately, our piece of paper that we're drawing on or canvas that we're painting on, it's not transparent. So we have to set it to the side or set it on our desk. We're still looking at this object that we're drawing. So this person, let's put a little, like a drawing of an easel here. And here's the piece of paper. Here's the canvas. Here's that circle that they're drawing. When they're looking at the circle, then they are still like seeing, they are seeing this. You can draw the circle small, you can draw the circle big on this piece of canvas. When you're drawing this circle like small, it's the equivalent of taking this picture plane and moving it closer to you. When you're drawing the circle larger, then it's the equivalent of taking the picture plane and moving it closer to the object. If you wanted to draw a big circle, and the circle is just a placeholder for anything, a figure, a building, whatever, right? So if you wanted to draw this circle much larger than it actually is, it's the equivalent of taking the circle. Let's do this on a clean piece of paper. Taking the circle, and we put it in front of the picture plane. And then when we project that, we get a larger than life circle.
Good.
So this canvas, this piece of paper, if we could take it and slide it over here in front of us, in between this, then we can, like I said, we can just trace it. But we can't do that. So we're drawing it over here. This is the equivalent of this. These two are really the same thing. This piece of paper is your picture plane. This is the distance between the viewer and the picture plane. This is your horizon line. We talk about this line being infinity. And it is where everything disappears. If it goes far enough away and it's large enough. So the Earth is not infinite. The horizon line does not go to infinity, but it is very large. The Earth is very large, and it will disappear. Basically, it disappears right here at your eye level. If the Earth was smaller, then it would disappear lower than your eye level. So we kind of consider the horizon line to be right at the eye level at infinity. So we don't even need the Earth really to do drawings in perspective. If we had like the horizon line here, let's do a little separate drawing, and we did this little 1-point perspective box that we'll go over how to do really like soon. This is horizon line. It's actually infinity. So they're basically in the same spot. But if the Earth, the horizon, is not necessary to draw things in perspective, this could be floating in space. We can put some planets down here. Here's Saturn. And if this was not the edge of the Earth, we would still have a vanishing point for this cube if we were just like floating around in space. And this was all like stars and darkness. This is right where the viewer's eye level still is. The horizon line is not really necessary to have a point to put the vanishing points on. This, in this situation, this would be just considered infinity right here. But normally we're standing on the Earth, so when we're doing that, the Earth is very large and the horizon line is basically right at your eye level. Smaller things will disappear lower down just because we can't see, like a little bug that is crawling across the ground and it crawls over to the edge of the Earth. If we had eyes that could see that far, then this bug would disappear right at the eye level. But because it's so small, it will only get to a certain place where we just can't see it anymore. And so it's going to disappear below the eye level. So the viewer is looking straight ahead. They are looking parallel to the ground, which is the case in 1-point and 2-point perspective. In 3-point perspective, it's different. The viewer's looking up or they're looking down. But in 1 and 2-point perspective, the viewer's line of sight is directly parallel with the ground plane. So in this case, the viewer's looking right there. This is a 90-degree angle to the picture plane. So you can only look at one place at a time. So you only have one center of vision. The viewer can only be in one place at a time. So you only have one station point. The center of vision is also your 1-point vanishing point. You only get one 1-point vanishing point, and it is always at the center of vision. The cone of vision, we call it a 60-degree cone of vision. Probably because we have triangles that draw 30 degrees. So we have this triangle has 30 degrees, so it's really convenient to set this down and go, there's 30, and then there's 60 for your cone of vision. It becomes a little warning zone for you that be careful not to go too far outside of this because things start getting distorted. They start getting distorted right when you leave the center of vision. Here's an example. Here is the plan view of the picture plane. You're looking straight down on this, and this is the distance from the viewer to the picture plane. This is our station point. Let's go back to that circle as an example. So here's circle. So we draw that, project that onto the picture plane. to the viewer's eye. And this is the visual pyramid. And it's hitting pretty close here to 90 degrees. The image that will be on the picture plane is going to look like this, just a little bit smaller. This would be what the viewer would be tracing if they traced it on this piece of glass. So if we had something way over here, I'm going to try my best to do this same circle. And we draw a visual pyramid. And you can see how much longer this is than this one. If you're standing here and you traced it, this is going to look like an ellipse. Not going to be looking like a ball. It looks like a ball from this point of view. If you're standing right here and you're looking like that and you trace this circle, if you stand right here, right in the exact spot that the station point is, it will look round. But if you're standing over here and you're looking at it, it's going to look like an ellipse. That cone of vision would come out to, about here. Here's our 30 degrees, 60 degrees. So this is the area that you could probably draw inside of, and where the distortion's not going to be too unacceptable. It's going to get more and more distorted as you go. So the only thing that's not going to be distorted is if it was directly in front of the line of sight. These will not be too bad. But when you start getting over here, then you can see the things start looking like they're stretched out. So you want to always try to stay inside the cone of vision as much as you can, or at least not go too far beyond it. The other thing, I think this is the last thing we'll talk about in this video, is the measuring line. So the measuring line is just our scale. If we're going to draw something to scale, we need to measure it. So it's just like a ruler. And the things that you draw right at the picture plane, they are actual size. See, if this ball was touching the picture plane and you traced it, it would be the actual size of that ball. See here, when it's back behind here, it's smaller than the real ball. And then when we put it out in front of the picture plane, then the drawing is larger than the actual ball. So the only place in your drawing that's ever going to be the actual true size is going to be those things that touch this picture plane. So this is where we can put our ruler. And so we put it here, usually right where the picture plane hits the ground. It can be other places, but most of the things we draw set on the ground, so it's usually most convenient to put our scale right here on the ground where most things are setting. This is to measure horizontal distances. If you want to measure height, then the ruler, you just turn it 90 degrees. And we put our ruler here using those same increments. Measuring depth is the tricky part because those are foreshortened lines. These don't have perspective to them. They're just vertical lines are vertical, horizontal lines are horizontal. It's the ones that go back in space that are the harder ones. For those, you need a special tool that is called a measuring point.